Hello students, welcome to the final lecture on cognitive ergonomics. So in our previous lectures, we have seen and we have also known about cognitive processes like attention, perception, memory, and others. And here in this lecture, we'll be looking at how to design for attention or how to design for perception or memory, right? So let's get started. So first, let's look at how do we design for attention. So before we design for attention, so let's find out that when do we require users' attention, right? So one of the instance can be to alert the user of any unavoidable or dangerous situation which is at the present or which may come in near future, or it can be to alert the user of any new development in an existing situation or circumstances, or to let the users focus on important tasks or functions while they are performing any work, or it can be to command the users to take any necessary or important action, right? So you can see that so in our day-to-day lives, we usually require users' attention in any one of these cases. For example, let's take an instance while a driver is driving, and if the speed limit on a particular road is beyond a certain threshold, say 100 kilometers per hour or whatever, so the user is notified, and he may be asked to sort of lower down the speed, or it can be like any new development in an existing situation, which can be, say, the fuel tank is getting empty, so he can be notified, so he can sort of refill. And or it can be any other thing, like in Facebook you are getting sort of notifications or any new friend request, which is an sort of a new development in an existing situation, and you should sort of check your notifications and all those things. So these are the instances where we require users attention. So please relook at all these points. And then now once we have identified the instances which requires users attention, now how do we get users attention, right? Through visual means. So one of the way is through the use of contrast. Now what is contrast? Contrast means basically creating differences between elements or visual elements in regard to say colors, like opposing colors, or opposing textures like rough or smooth, different shapes, large versus small, or use of different lines like a thick line amidst various thin lines, orientation, typeface, etc. So let's look at color. For example, you see here all these are like black boxes, and amidst all these black boxes there is one sort of pink box which is of different color, and since this is of a contrasting color, so it is also getting your attention, right? So you can see like it is the same concept is sort of implemented in traffic lights, where the red color in the traffic signal conveys a stop, right? And why red color is used? Because it is visually distinguishable from the surroundings, and also red light is least scattered by smoke or fog. And also red is also associated with the sign of danger. And also you see here red has been used against a bluish background, uh, so, and this marks for unread notifications and alerts in a Facebook page, and users will spot these elements amidst other information which is there. So because this red sort of stands out, and since the size of this the patch which is red in color is not too much overpowering, so it is not seeking too much attention from the user. So he can any time sort of go back and see his notification after going through the the main information in his wall. So the next is the call to action button. So call to action buttons are basically the buttons which urges the user to perform a specific or important function. For example, as you can see here, the call to action is the join fee for a month, which is stated here. And let me highlight this out. So this is the basically the call to action button, and you can see this button is larger in size, and it is also having a color contrast with respect to the other elements in the web page, so that it seeks your attention, right? So the user's eye gaze would be primarily focusing on this area. So this is what call to action buttons are, and they are designed so that they can seek users' attention. And similarly, even in physical interfaces, we see the buttons are red in color here, which sort of pertains to the more important functions like switching on or off, or buttons may be sort of emissive in nature, so they may have a backlit to sort of make them stand out from other buttons. So the buttons which stands out from the other buttons, usually special functions or more important functions are assigned to them. Similarly, we also see in signages that in airport signages you see, and the use of yellow against black sort of also stands out in the surrounding, and user is sort of we usually sort of spot this amidst all the noise or all the elements in the environment. And similarly, for see the colors which are used in the signages, like red, black, uh, and red stands for this should not be done, and also see yellow and black, which creates a good contrast. So now we contrast through colors we have seen. Now contrast can also be created through shapes. Like there is one this the triangle which is standing out from the other shapes of circles. Contrast can also be created by altering the scale. As you can see, this larger box is standing out from other boxes, smaller boxes. Orientation also, a distorted or a disoriented figure would stand out from other properly oriented figures. And also change with the line thickness, and also different typefaces like this can sort of make this portion stand out from the rest. So these are the other attributes to create contrast apart from color. And then alternatively, motion graphics can also be used to seek users' attention. Like we can see like this letter is constantly glowing on and off. It is also seeking your attention. And also you see the loading screens or loading buttons, so they are sort of animated in a particular fashion so that they can get users attention while the next page is getting loaded. And also things like vibration and all, and also blinking colors. You can see some of these elements embedded in web pages which seeks for users attention. Now let's move on to the design for perception. So here again, so what are the factors to be considered is that when we are designing for perception, so there should be no ambiguity on the part of the users while they are perceiving any information, right? So here by information we mean that it can be any instruction based information. Instruction based information can be a manual uh, for doing any work, or manual to operate any product or whatever. So all this comes under the instruction, and also information can be a knowledge or a fact based or an event based which has already happened, right? So whenever there is a sort of a communication of any information from one individual to another, there should be no ambiguity, so that so whatever the creator of that information has thought of, the listener or the perceiver should also perceive it in the same light as the creator of that information. And also, in case of branding or promoting any new product in the market, customer perception is built or it is altered in order to sort of favor the sale or use of a product, right? So here also, when we are sort of pushing any new product into the market, then we know we need to sort of build what customer would think about the product, right? If they think well about your product, a product can be a physical product, or it can be any sort of virtual product. So product is an umbrella term. So if you are pushing any new product in the market, so you should think of ways of where the customer is sort of having positive impressions about your product. So there again, perception plays an important role. So how do we build users' perception? So so first one is to sort of when we are sort of passing on any instructional information, so to we should be avoiding any possible instances of misinterpretation of any instruction based information. So in order to do that, so information can be broken down into smaller or simpler chunks, and multiple of these smaller simpler chunks can be sequenced, which are easy to comprehend. And also text-based instructions can be supplemented with graphical elements or illustrations or audio visual elements. So let's take the example of have a task where a user needs to sort of insert a sim card or inside his cell phone. So so one instance can be I am laying out all these steps one by one. I am sort of say the manufacturer has laid out. In contrast to this, think about a way where uh, the graphical elements or illustrations has been used in a step-by-step fashion, so that users understand as to how he should be placing the memory card inside the phone. So now if you compare the text versus graphic, uh, in which instance do you think the user would have lesser ambiguity? Obviously, in the graphic-based, uh, manual. It is because whenever the text can be sort of interpreted in a more ambiguous way. For example, here if you see if you take any statement like carefully insert the ejection pin into the hole on the tray, ensuring it is perpendicular to the hole to avoid any damage to the phone. Like then the user can ask which is the ejection pin, maybe or on which hole on the tray is the manufacturer talking about. So there are many, there can be many sort of holes in the phone, and so things like that, right? So the text can lead to more ambiguity, whereas the no the graphical or images can lead to lesser ambiguity. So again, so this brings us to this point. So the text-based instructions can be supplemented with graphical elements, especially when we are dealing with instruction-based information, like in a product manual, right? Now, moving on, how do we build users' perception for any existing or a new product in the market, right? So to create a desired perception for a new product, which is to be sort of pushed in the market. So stories or narratives can be used, or even metaphors or analogies can be used. Let's see some of the very top examples from Indian advertisements. So one of the example is like Happy Dent, as you can see, like they create this story about the as if you sort of chew Happy Dent, then the teeth will glow like anything. And even Fevicol, which is a good ad, like uh, it's uh, it's uh, it's like it binds people together, or it binds anything. And even it is also evident from their logo, like if you see uh, that the two elephants are sort of having a sort of tug of war. It signifies strength, and also this image where bonding is always there. And also in this advertisement of this popular mango drink, where even if the drinks are sort of synthetic, or it is projected in a way that it is made from pure mango pulp or things like that, so as to create this perception in users mind that it is quite natural of a drink. So like this, stories can be created around products or around brands, so that customers perception about is a certain perception is built, so that the customers will only sort of favor using the products of certain brands. So this is how perception is built. Moving on, let's see design for. So in design for memory, let's see what are the factors to consider. So the first factor is that user should not be made to memorize a very large chunk of information which is unnecessary. So you should only make sure that users are only required to memorize only that piece of information which is necessary, and even necessary information should be smaller in size. For example, it can be at max a 4-digit password or things like that. The second is that users should be made to recognize any piece of information rather than having to recall or retrieve from the long-term memory. So recognition can mean like recognizing particular any information like capital of a country or something like that. Like an example of recognition can be is suppose I ask you a question like, is Itanagar the capital of Arunachal Pradesh? Versus a recall can be, I am asking you what is the capital of Arunachal Pradesh. So a recognition, you are given more cues, more options. Recall means you are given less options or lesser cues, and it calls for more of cognitive processing to sort of retrieve information from the long-term memory. So you should always make sure that users are made to recognize rather than recall. And the third factor to consider is that the task should be designed in such a way that the user is learning only at the first time while doing it, but not while every time while he is doing the task, right? So for example, you are using a graphic or image editing software, and you are exercising a command to manipulate a specific image. So ideally, you should be only learning for the first time, not whereas you should not be forgetting it every time, and every time while you are executing the same function you need to go through the manual or tutorial. So that's a bad practice. So again, let's focus on what the recognition over recall is. So let's this is an example or a screenshot of the MS Word application, and suppose while you are opening any recent files, so the it is already the list of the recent files are already listed here. As you can see, it is already listed here, so that user is not made to struggle through the exact name of the document they should be opening, because user might not be knowing the exact name of the document he might be opening. But if he is given the options of the recent files, he can sort of choose from it. He can recognize which file he wants to open, which of the one of the recent files he wants to open, and he can open accordingly. So again, this is a screenshot from the UPI app, and as you can see here, the recognition over recall, only the last four digits of the account number of the user is highlighted, so as to so as to make the user aware of which account the transaction is taking place, from which account, right? So he or she might be having more than one account. So this last four digit can help him recognize from which account the transaction would be taking place. And also, as you can see here, for entering the UPI pin, only four digits are required, not more than four digits. So so in this way, a user is not made to remember larger chunk of information, but only four digits at maximum. So this is another example of avoiding recall, where the long forms are usually filled through autofilling, so that user will enter his name at the top, and whatever previous data was entered with respect to that name, exactly all those relevant fields in this new form are filled accordingly, so that user is not made to go through the entire process of filling the form again. So this is one of the one of the good examples of avoiding recall, right? It also saves users time. Now let's take a look at this picture and think about the first time when you would be operating the handle. So how would you respond to it? Well, you might be thinking that, should I turn it or should I push it? So here comes the important aspect of recognition, that product should be designed in such a way so that the users should automatically deduce its functionality by perceiving or looking at the form itself, rather than going through a product manual or asking anyone how to use a product, or taking some time to figure out how that product actually works. So here the recognition factor comes into play, where the functionality of the product should be quickly be sort of understood by the users at a first glance, right? So this might be a very creative product or a creative door handle as shown in the picture, but in terms of functionality, uh, with regard to the existing mental model of the users, it might not be a very great design, uh, taking those aspects into account. And now let's do a quick exercise, right? So just take a look at this screenshot of this web page. Well, now it's time to recall. Now let me ask you, what do you think? What was the web page about? So this is also called a 5-second test. And what do you think? What were the key elements or components that you remember just now? Just the web page which you have seen. So you are not allowed to pause the video and go back and check, but think about it. What are the things you are able to recall? So what was the web page about? You might say that it was about some society. You might see that it was IEEE, something like that, and things were there to so as to sort of join the membership and things like that. So here comes the important point that you will only recall those things which have caught your attention, right? So usually there can be some buttons or call to action buttons, or there might be text embedded in some sections which caught your attention, and those are the things you are sort of uh, are able to recall now, right? So basically whatever elements you have designed in your web page for seeking attention may be retained in your memory, uh, right? So yeah, so this is also called the 5-second test, and you can also use it in your projects of both interaction or visual communication, right? It's a test of recall, which is also called the 5-second test. Okay, so what are the important, so few of the important points. So chunking is an effective method of presenting groups of content in a manageable way. And so suppose you are having a large amount of content, so you should, chunk or group those content into 5 to 9 items at a time, because in our working memory we can hold up to 7 plus minus 2 items. So there are limited number of items we can hold in our working memory. So one of the previous example which I gave in the last video was, when we are sort of remembering any phone number, 10-digit mobile number, so we usually sort of chunk that number into, say, 3 or 4 pieces, so that we are able to sort of keep it in our working memory for a short amount of time, for say writing it down or things like that. And there is another thing which is also another effect which is called serial proposition effect, which is also called a primacy and recency effect. So which was proposed by Hermann Ebbinghaus. So he said that users have a propensity to best remember the first and last items in a series. So suppose if you have a list of items, uh, you have shown the user a list of items, the users would be most likely remember or recall the first item and the last item in the series. And because of this, you should be careful about what items you are placing in the first and last item in a series. And you should also put the least important items in the middle of the list. And let me give you an example. Suppose there is a playlist which I sort of give you, and there are some random sort of songs or compositions there. So most likely you might be selecting the first or the last uh, of the songs in the playlist, or you might be sort of after you have gone through few of them, so the first or the last compositions which you have heard, you would be better recalling than other compositions which were there in the playlist. So these are the few of the important points related to memory. And whenever you are designing for memory, make sure that you are having all these points as thumb rule. Next, we go for design for information processing, and here we'll look at a law which is called Hicks law, which states that the time it takes to make a decision increases with the number and complexity of choices, right? So it was proposed by William Edmund Hick and Ray Hyman. It is also called Hick-Hyman law. They proposed this law in 1952, and they basically examined the relationship between the number of stimuli present and the individual's reaction time to any given stimulus, right? So if I give any individual more stimuli to choose from, he or she will take a longer time to decide which one to interact with. For example, uh, suppose you go to a newly opened candy shop in the city, and they are having a wide variety of uh, new candies which are equally good. And and suppose if I tell you you have to pick only one candy out of this several candies which are displayed there, think about how much time will you take for selecting one candy out of such equally good looking new candies. So obviously if the variety is more, the time taken by you to decide which one to choose will also increase, because it follows an equation. So given n equally probable choices, the average reaction time t required to choose amongst the choices is approximately t equal to b log to the base 2 n plus 1. So what it is about, let's see. And so as you can see here, t is the time taken by a user to make a choice. B is basically a constant, and n is the number of choices which is presented to the user. So if n increases here, if n increases, then what happens is that log to n plus 1 also increases, and hence t also increases, right? So if n sort of increases, so it means that t, which is the time, it will also increase, right? Sorry about the writing here, because I'm not having a pad or digital writing pad. But anyways, you got that idea that if n increases, which is the number of choice, the t also, the time taken to select a particular uh, stimulus will also increase. Moving on. So let's see the implementation. Suppose you go to a pizza shop, and you are going through the menu, and this is the menu which you are presented with. Think about which is the pizza you will order. Suppose you are going here for the first time and you are not having any such preferences, right? And so obviously, so it is the information here is all very much cluttered, right? So to help customer make better decisions, let's look at each of this thing, that you should reduce unnecessary information. So there may be many redundant information here. You should sort of eliminate it, and you should always categorize information in groups. For example, there can be some mushroom-based pizza, or there can be some vegetarian pizza, or there can be non-vegetarian pizza, or whatever can be the categorization. And also the most important thing is make information readable. So in one sheet you should have less information or less data. The information can be sparsely positioned. Instead of like this, information can be in one sheet, can be like this, instead of putting it down in a list, it can be something like this, right? So you have the the name of the pizza, and also the description, and also a small sort of a picture here. So thing like that. And text should be aided with graphics and illustrations, right? So you can obviously redesign such menu into more sort of a readable, legible menu, where which will help the customers to sort of decide on what item to choose, and this will also help them to sort of reduce the time to process the information, right? And then let's come to the section of designing for motor response. Here, here also we'll be looking at a law which is called Fitts law. So Fitts law is basically a law which is proposed by Paul Fitts, the psychologist, in 1954 and 60s, and it states that the time to acquire a target is a function of the distance to the target and the size of the target. So let's look at this one step by step. So the time to acquire a target, so the target can be like pressing of a button in a machine on a machine interface, or it can be like clicking an icon on the desktop. So the time taken by the user to press a button or click an icon is a function of the distance to the target from a source point, and also the size of the target, right? So what does it mean? It means that the user will take less time to hit a target, say click an icon, if it is near to the mouse pointer, uh, or if it is also large in size, right? Also, users will avoid wrong selection if the inter button spacing is increased. So if two buttons are if two icons are say closely sort of kept to one after another, then there is a larger sort of probability, I mean there is a greater probability that the user may sort of select the wrong icon, right? So see here, so suppose this is the cursor start point, which can be in the middle of the screen, and this is a target. It can be an icon, and W is the say the width of the target, and D is the sort of the distance, the minimum distance from from the cursor start point to the center of the icon. It says that the time taken by the user to click on this icon would increase if D increases, and the time taken by the user to click on the target will sort of decrease if W increases, right? So if the width increases, width of a target or the width of a icon increases, so the time taken by the user to hit this target would decrease. But conversely, if the distance increases, then the time taken will increase, right? So obviously it means that the farther away this icon is from the cursor, then the time required to acquire this target will be more. But if the target is say large enough, or if the target is wider, then the user will take lesser time to sort of hit the target. So this also comes with equation, and the equation is like t equal to a plus b log to the base 2 1 plus d by w. So now a and b are constants basically. T is the time taken by the user to hit the target, and this d is basically the distance of the icon from the cursor start point, and W is the width of the target. And as you can see here, so log to the base 2 1 plus d by w, this is also called ID, or index of difficulty. And if d increases, that is the distance increases, this whole function will increase and t will increase. So if d sort of increases, so t, which is the time taken, will also increase. And if W, which is the width of the icon, increases, then what will happen? T will decrease, right? Because W is in the denominator, right? So if the distance to the icon increases from the cursor start point, then the time will increase, and if the width of the icon increases, then the time taken to hit the uh, icon will decrease, right? So that is the sort of idea here. And there are a few implementations of this Fitts law. So suppose this is the screenshot of the Gmail, and you see that if you hover your mouse over each of these uh, functions here, so you will see this whole region is has been selected, right? So whenever you are checking on your sent mails, you need not take your cursor over to this, the later letters here, but you can even sort of click here also, in this region also. So the zone of influence of this whole button spreads all over it, all over this region, right? So so this is one implementation of Fitts law, where the width of the uh, an icon is sort of enlarged so that the time taken by the user to hit it will decrease. And also here, as you can see, the icons are sort of arranged radially. So suppose if your thumb is here in this region, so you are able to sort of quickly sort of access each of these functionalities, uh, because the distance of each of these functions with respect to your thumb is minimum. So if the distance is less of the icons with respect to the tip of your thumb, then the time required to acquire the target, which are these icons, will also decrease, right? So the idea of Fitts law can also be extrapolated to physical interfaces, and in this image, as you can see, this is a model of a washing machine by GE, and as you can see, this is one of the primary controls of this machine. And functions, I mean, the buttons like this should be placed directly in front of the user whenever the user is operating with this machine, because if they are placed in such areas, uh, uh, you know they can be easily sort of acquired by the user, right? So this is the D component in the, you can think of this as like the D component, which is the distance component, distance uh, of the control from the user. So if that is sort of lesser, then the time taken by the user to complete the task will also be low, right? So the main functions or the main controls should be sort of closer to the user, right? And so this brings us to the end of this lecture. Thank you, and please sort of upload your the major project, the second part, which is the conceptualization. Few of you have submitted, but the majority of you did not submit. So let's have those submissions in the drive, and yeah, stay tuned.